ahead and get started. I waited a few extra minutes just for the stragglers. So just a little bit about myself. I'm the senior manager of operations for BestBuy.com. I'm an ops guy. You know, I love monitoring, so it's pretty cool to see all these people show up. You know, it's a passion of mine. So I just want to take a quick poll. Like, how many people in here are ops people? How many people are like devs, managers, other? What are the others? Like, what do you guys do? IT audit. Anything else? Cool. I'm just curious, because again, this is my stuff. This is like, you know, what I do every day. So it's great to see so many people show up. So this talk is called All the Monitoring because there's tons of tools out there. And you know, a lot of people think they're kind of stuck to a lot of the common ones that are out there, like Nagios. So the little meme here is, you know, you mean to tell me I don't have to use Nagios? And the answer is no. And you know, BestBuy.com, we have a lot of challenges because of our scale. So we have this thing called Holiday that, you know, makes our website grow pretty insanely. We're the third largest e-commerce site in the world during Holiday. The only people that beat us are Amazon and Walmart. So we have a highly variable workload too. So we have multiple cloud providers that we use. So we have instances that come in and out at all times. So a lot of the common old tools can give you a lot of pain points there because they weren't designed for cloud computing, configuration management. They're very rigid and geared towards kind of these old static infrastructures. So I'm not here to bash any tool necessarily, you know, but I can if you want me to. You know, I love to troll them. You know, Nagios is a good example. Honestly, it's a great tool for. It was designed, I don't know, what, a decade or more ago. But again, it hasn't adapted to the way infrastructures have adapted over the past few years. So the goal, normally in my talks, I do these like live builds and demos, and I ended up with 62 slides, and I have 40 minutes. And I like to leave time for questions. So if I have time, I'm gonna kind of just show you some quick like demos as I'm flipping through. But I'll be happy to stay after and talk to people. So it's more gonna be slide driven. But you know, the goal here is to have an open source monitoring system. Yep, we're a big enterprise, and you know, you'll see all but one of these tools I'm gonna talk about today we use, and I'll tell you why we don't use the other one. We're aiming to be simple, malleable, and scalable, and you know, compose your system to your requirements, and don't tie yourself to a single monolithic piece of software. I should be able to next year pull one of these out if I want to, because something better came out. So choices, there's hundreds and hundreds of choices. Open source, enterprise. Another quick poll, how many of you are buying some really crazy expensive enterprise monitoring tool? Like, just one of you, wow. 2, 3, okay. See here, everybody doesn't, kind of ashamed to admit it. So, yeah, it's kind of ashamed to admit it. It's okay, we've done it too. And one of the tools I'm gonna just briefly mention, it's an enterprise tool, and we pay a lot of money for it, but it's very valuable. So I left out a few, and mainly the ones I'm going to talk today, and minus the other hundreds and hundreds of enterprise tools. So like, here's the things that you do need, though, right? And everything in this list except one bullet point I'm going to cover today, and I'll explain which bullet point I'm not. So system metrics, CPU memory, you know, your disk stuff, you know, all the normal process stuff. Application metrics, you know, you should know how many 500 errors are happening on your website, or, you know, hey, you should also know how many 200s are happening as well. So latencies, service timings, log files. So I mean, it's the heart of your application. Synthetic monitoring. This is the thing I'm not going to talk about today. I have a couple bullet points of other things to look at the end of the talk. There's some good enterprise products here as well, and there's a few open source things that you could stitch together to do some good synthetic monitoring. Rates, aggregates, and state. And you should just be able to graph everything. So I'm just going to revisit the guiding principles really quick here. Simple, malleable, scalable, open source. Compose it how you want it, and don't tie yourself to some monolithic piece of software. Which some of the other, even like a zabbix, it's very built around itself. It does have some like APIs and stuff like that, but you'll also have challenges scaling it. These are the 4 tools that I'm kind of going to talk about today. The first one is Sensu, and has anybody heard of Sensu in this room? Cool, a few, that's awesome. So Graphite, I'm sure more of you have heard of, CollectD, and Logstash. Now, I kind of lied here because if you have money, buy Splunk. Logstash and Splunk. Logstash is a free open source log delivery and indexing tool. Splunk is an enterprise product. It is expensive, but it is one of my favorite tools to use. And I'm not going to talk about it here today, but huh? It kicks ass. Exactly. So, all right, let's do this. So, Sensu, it's a monitoring router and framework. So, when I talk about the tools earlier, and you think of a Nagios and some of the basic stuff that zabbix gives you, this is what you're going to replace it with. Sensu it only cares about the bad state. So you're only ever going to see what is critical and in warning. You're never going to need to care about the good state. And this is a complete mind shift in it. And when I first started looking at this, I had a hard time getting my mind routing and grasp. But like once you actually break free from that and just trust that the things are working right, because you'll know when it's also not, your life is going to be so much better. Because like a Nagios, you just get once you start drilling in and you figure out where the hell you are, and then you see all the green, and do you really care about all that? Or you really want to see what's bad? Because from an operations point of view, you just want to know what's bad, and you want to know that quickly. Or this is the Nagios object relationship. This is insane. This is Sensu. So in a very simple state, you have clients. Those clients subscribe to something. So your subscriptions are like roles. So like I have a web server role, and I have a database role. And they can actually subscribe to multiple things as well. You could have like an all role where everything in your infrastructure is going to get this thing. And then you have checks and a handler. And a handler is actually what happens based on the bad state of the check. OK. Yeah. So Sensu, it's simple. You have a check. You get a result. It can turn into an event, and then you handle it. So checks, they output data to standard out or standard error. And they use the normal exit status to indicate severity. So this is actually compliant with what Nagios uses. And what you're going to see in a second is that you can actually use your Nagios plugins in Sensu. So your cost of switching is way lower. And there's I don't know, thousands of Nagios plugins. So you're not going to pigeon yourself into Sensu in its world. You're going to see that it's very flexible, and you can run whatever you want. This is what a check looks like. So this is a check disk, and you pass in a couple things like warn me when my disk is 85% full, throw me a critical when it's 95% full. It runs every 30 seconds, and it will alert me every 30 minutes based on if it continues to fire. I've also told it to only fire if it happens twice in a row, because I typically do that in most cases to just weed out some noise in the system. And this is an example of using a Nagios plugin. So all I need to do is point to the plugin, and I provide the same parameters that you would for Nagios. So check the process, the chef client process, and warn me at a critical if it is below 1 or greater than 9 processes. And then every check, so the checks are what I just showed you. So it's going to have this output, this exit status. It gets inspected Is it the first zero exit status in a series? Is it marked as a metric? So I also said that Sensu can be used as a monitoring router. So you can actually send all of your metrics through Nagios, and you can actually inspect them too to do something based on that. And then it creates an event based on if it's a bad state. What does the event data look like? It has some client information, and I actually had to cut this down. I took a grab of one of my servers, and I just couldn't fit it all on the slide. But you can jam anything you want into the client data. This is a rel box. I actually had to cut out the rel line and where it's at and the IP, and you can have what rules this thing has. Like you can put any data in here, so you get that in the check data. So another thing you can do is if you have a graphing tool, you can plop in a graph to this server and this metric. So you can easily, when you get that alert, click on it and go right to the graph to see what the thing is, or you can provide some documentation links. So if that check disk or whatever it is, this is actually a front-end HTTP check. So if the front-end HTTP check fails, you can put a link in there for the rest of your team to the documentation on what to do when this thing actually happens. And then it provides some check information, timestamps, what it was, what should handle it, and how many times it's happened, stuff like that. Handler is what actually takes the action on an event data. You can execute a script. You can open a socket and do something. You can send it to PagerDuty. You can send an email at the simplest state. It's whatever you want it to do. The handlers are really easy to write. There's a bunch in the open source community. And I'll show you a couple examples. So this is what a handler configuration looks like. It's super simple, and just points at the file and what severities to watch for. The good? So Sensu is scalable because it uses an AMQP protocol, and it does Keepalive. So when you have a network event, Nagios is going to spam the hell out of you with about 50,000 alerts based on every single check you have and every single server you have. That's not going to happen with Sensu. What Sensu is going to tell you is, hey, I have a server, and I'm having communication issues, because it's not able to do the Keepalive. So you're not going to get spammed with all that stuff that actually is failing on the server. You're just going to get the Keepalive event. This is also how Sensu manages things coming and going. When something comes up, it checks in with Sensu. Sensu says, hey, this thing is new. I should just start treating it like it's one of my citizens. When things go away, it says, hey, something has stopped talking to me. And what we do is we have a handler that says, we check the state of that machine, and if we've expected it to go away, we remove it from Sensu. So we use Sensu itself to just detect when things have actually naturally gone away. If it hasn't naturally gone away, then we handle a normal event pipeline for it.
But at least you can set thresholds, so you don't get a lot of false positives.
Yep.
Just whenever you've got noise or you've got excessive traffic or something going on, you don't have to, things hiccup.
Yep, absolutely. So it's compatible with Nagios plugins. The cost to switch is very easy. And you can utilize anything for your checks and your handlers. If it can run on the machine, you can use it. It could be Ruby. It could be Python. It could be Bash. Sensu itself is written in Ruby. And as a Ruby app, it has a pretty lightweight on the server. If you're constantly running checks, it will use about 1% of the CPU. And I think it's either got 12 or 24 megabytes of RAM utilization is about what it uses. So it's pretty lightweight for a Ruby app. And it's actually I think the brand new version just got shipped with Ruby 2.0, which has some performance improvements in it as well. So deep merging a configuration file. So you can use your configuration management tool to just set these checks up in these handlers one by one. Single configuration files, you don't have this big monolithic file that you're like searching through. As long as you drop these things in. What do you mean by variations?
If you want to go ahead and make sure that people are basically keeping their servers, they're not going off of your corporate build, this can also be used as a compliance?
You could. You could have a check that checks the the fingerprint of that machine. So like say it has to be a specific build. Like we do the same thing. We have gold builds that we get certified by our security team, and then we build off of that thing. So you could have a check that is designed to check for specific fingerprints on that machine to determine whether it's the right thing or not, and you could get alerted on that.
Yeah, because you can use like Tripwire and other tools like that for like system file integrity
Yep.
checks and things like that. But I was wondering how you guys actually make sure that you keep your servers in compliance as far as making sure that they don't sway from the corporate standards as far as the build standards.
So we use Chef as well pretty heavily, which we use for the kind of configuration management state of things. We're not really doing it from a compliance perspective with Sensu, but we maintain the state that we expect the machine to be in with Chef. So, but you could do, I mean, like you could use Sensu to do some sort of check to say, like, fingerprint the machine and then say if this thing is not like it's supposed to be, alert me, right? So. So it does this deep merging of the configuration files. As long as you drop them in the directory, it automatically globs them in and works off of them. Groups and sets. So this is where Sensu has a subscription model. So you can say, I want all web servers to get this, and I want all database servers to get this, and I want all servers to get this. And then you can also say, when this check fires, I want it to do this handler, and this handler, and this handler. So you can actually fire off 5, 10, 15 handlers to do different things based on a check. So it's just this grouping model. Aggregates, so you can fire off a check against a group of machines. So you could say, I want to check all of my web machines and count the number of 200s, and if it's above this, fire off this handler. Or, I mean, most likely you'd probably do it from an error state, or if you have like some other sort of scaling state that you want to do, like total Apache request count coming in, and if you know your modeling of your servers, you could kind of like scale off that or something. Yep. 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 Yeah, so like we actually use the Nagios check procs to check for the processes that are running. And then what you can do is you can have a handler that says, if this process is like down, SSH into the machine, restart it, and so. It has flapping, so I didn't talk about it here. It has flapping detection. The Keepalives, the timeouts are actually hard-coded in Sensu, and I think it starts firing after 60 seconds. Sensu's open source. It's Ruby. It'd be 30 seconds to go change the timings on the Keepalives. Because it's done via the AMQP protocol, so it's actually Sensu uses RabbitMQ, and you could replace that with something else if you really wanted to, because it uses the protocol versus really locking itself to the tool. But it uses the default Keepalive chatter that happens between those. But again, it's an open source project too. I mean, Sean Porter's the main developer of it. I'm sure he would he'd take a pull request to make Keepalives configurable. So it's actually not a lot of code either. I think he's added a bunch of features recently, but as of I think the version we're on, there's only maybe like 1,300 lines of code or something like that in all of Sensu. So community plugins, there's a ton of them, and they're all on GitHub. This is an example of a get banner check. So this is fairly simple, and it tries to rescue some different conditions, but it's only a handful of lines of code. And what this is done, what's going to do is it's going to connect to the socket and read the first line, and then report back and do some regex validation on what you expect it to be there. Or you can do something more advanced, like this is our decommission, part of our decommission script. So what we actually do, when I was saying before, is when we have a machine go away, the first thing we do is we check the cloud provider that machine came from, and we see if it's in a state that, like a terminated state or whatever it is, or if it's still running. If it's in a state that we know, like, hey, we terminated this thing, we just start decommissioning it. So we delete it from our chef servers, we delete it from Sensu, and we send an email that says, hey, I've successfully decommissioned this thing. If any step fails, we say, hey, it failed. This is the step it failed on. Somebody might want to manually go see what happened. And if it's in a running state, then we just go down a normal pipeline of handling the event. So whether it's an email or firing off to PagerDuty or whatever it is. Yep. So I mean, again, it could do anything you want. So as long as you can tie into it, it's, yep. Sensu CLI. So this is actually something that I started creating a week ago or 2 weeks ago at the Monitor on a Hackathon in Boston. There was a challenge to create a Sensu CLI, so I started creating it. It's in GitHub today. And I'm still working on all the features, but it's got a command line thing now where you could actually say, Sensu clients and get all the clients, or you can actually silence a client, or you can silence a check right from your command line. Collectd. So this is my next topic, and I'll leave some time for questions at the end too. Like I said, I ended up with like 62 slides, so I'm just going to keep moving unless somebody stops me. This is where you're going to get all your system statistics. So it's just a daemon that runs on the machines. There's really not a whole lot to talk about this thing. It's written in C. It's very performant, very low overhead. There's over 90 plugins. And I think today we get like about 150 metrics per machine from Collectd or something like that. And it outputs to Graphite. There's other output handlers for it, so it writes to other places as well. I say Graphite because I'm going to talk about it, and that's what we use. It's very simple to set up. Each plugin can run at different intervals. You can have one run every 30 seconds and one run every 60 seconds if you want. This is an example of a plugin configuration. It's really simple. Load plugin memcache, provide where it is and the port, and that's all you have to do. And it's going to, I think it collects like 20 different memcache metrics or something like that. Graphite. It's a scalable, real-time graphing engine. So it's a time series database. It's similar to like your RD and ganglia world. It's way more flexible, and I'll show you why. So we graph everything. There's nothing more than leaders love than graphs and pretty charts. So. It's a time series database. It's called Whisper. It's different than RD, and it's a powerful rendering engine. RD versus Whisper. RD cannot take updates in time slots prior, so you can't like go in the past. And it wasn't designed for irregular updates. Whisper is slightly slower. It's written in Python, but we're talking about less than a millisecond, nothing that really most people care about. Unless maybe your Twitter, but actually Twitter uses Graphite some, and actually the core maintainer works at Twitter. So the render URL has an API, and what you do is you provide it some kind of like RESTful-like query parameters, width 960, height 505, and that's going to be the width and height of your graph, and then what you want to actually graph. Like this is the super simple, basic example. This is like probably the minimum viable to get a graph. Actually, it probably defaults a width and height if you don't even provide it, so you might even only have to provide a target. But that's beginner stuff. Derivatives, draws infinites, highest average, Holt-Winters aberrations, logarithms, most deviants. There's hundreds and hundreds of ways to manipulate the data in the graphs. This is an example of port 80 connections with using Holt-Winters confidence bands. And you can understand when you're having an aberration in your environment. So how do you get data in? It's super easy. Just like I think a lot of this other stuff I'm talking about. You open a socket, you send a string that is basically the hierarchy of the data. So this will be in a Sensu bucket. Under the Sensu, there will be an instance bucket, which that would be like your server name or whatever it is. And then under that, there's a check disk. You send the metrics. So I'm writing a 1 here, because what I'm saying is that this specific metric is like we graph when our alerts fire. So we draw a 1 when there's an alert firing, and then you pass it an epoch timestamp. And then you close the socket. And that's all you need to do to get data into Graphite. And this, actually, is where, oh yeah, the resolution is super ghetto on this thing. This is, actually, I was going to show you, and I wonder if somebody cleared it on me. Them jerks. I have a little test environment set up, and I totally nuked a process on a machine. And I was going to show you just how it shows. But normally, you'd see the bad state here, and that's all you see. This is the Sensu admin. But this is Graphite. This is like the default user interface. Once you actually start using Graphite, you're really not going to use this a whole lot. It's kind of for the beginners, and it's not a great interface, but it works. I just took Carbon, which is what Graphite uses to write the metrics to disk, and just graph. This is a test machine, just how many metrics are coming in per minute, and then you can apply tons of different functions to this thing to manipulate the data, as well as you can do graph options, and there's tons of different things you can do to change. There's functions that aren't even in here because they're kind of hard to do from a little UI perspective, and that's typically where you start doing it from the URL API. This is just an example. I was going to show you a little bit more advanced example. So we're passing in a bunch of different stuff. We're doing different axes for metrics. So we have some on the left and some on the right. And we're averaging the series of stuff, and a lot of magic that happens in here. So I don't know, I wrote this and I don't even remember what's in it. So that's Graphite. Logging. So Splunk is by far the best tool. It costs some real money. You can get a free version if you only log 500 megabytes per day. Not a lot of people do that, but if you have a super small, if you have a single box, do it. So Logstash is a great free alternative. It's not as powerful though. It's an open source log management tool. It ships logs. It will parse them based on things you set up and indexes it, and it uses Elasticsearch to search that stuff. Don't use the default web interface for Logstash. It is mega ghetto. There's this thing called Kibana that is written in Ruby, and it's a different user interface for it. And I think they're going to mainline it into the project. I just don't know when they're going to do it. But it allows you to search. It allows you to graph things. And it allows you to score trend average stuff. And I actually have this is the default user interface actually right here. And I can let me type weather or something. It might the process on my machine might be nuked or something. But this is Kibana. It's a little bit more robust, and you can drill in on things. You can look at different things. You can change your graph, your time based on dragging over the graph. It's still kind of very basic. Logstash gives you a lot of very powerful stuff, kind of on the back end on how you filter things, and you can do different events on the back end based off of things that you set up. Splunk, I'm trying not to talk about it, kind of gives you all that really nice right out of the box in the interface. You can build dashboards with it. The search is way more powerful. How does
Logstash store the data on disk? I mean, that's one of the nice things about Splunk. It does the map reduce compression data.
It uses Elasticsearch. So what Elasticsearch does is it uses its they have it set up to index the data in a certain way, and then it's using Where Splunk, like they have their own like chunking algorithm or whatever the hell you want to call it to take each like tag or whatever it is of the data, where they're using Elasticsearch to do that for us. So like they're taking in the data and they're letting Elasticsearch index it, and then you're using the Elasticsearch search API basically to search against that data and how Elasticsearch index it. So Elasticsearch is a pretty awesome tool. It's very easy to scale as well, which is a good reason why they chose it for Logstash. So where the hell did my talk go? There it is. Logster. So we use this internally. It generates metrics from log files. So it basically parses a log file. It maintains a cursor, so it's not like rereading the entire file every single time. But it lets us, we can count our Apache Access logs and say, count the number of 200s, count the number of 500s, 404s, whatever other error code you want. And then we ship this off to Graphite. And this allows us to build nice dashboards and graphs based on really easy metrics pulling out of the logs. It just basically trolls your logs. So logs can be the heart and soul of your metrics. So this should be your richest source of data. And if it's not, you're probably logging wrong. And I'll just give some basic bullet points on how to make some of your logs better. Use a standard time format. Every developer thinks they should use their own like custom time format, and you can never get them matched up. Some of them like don't have time zones or seconds or whatever it is, and like when you're actually trying to correlate different events that are happening, and when they can actually be the same thing and your timestamps don't match up, like it makes it really difficult to do. So you put the time at the beginning of the file, go to the finest grain point you can, so milliseconds. Use unique identifiers, so like at the top of your stack, just start passing something in a header or a cookie or whatever it is. That is that's UTC actually. It's denoted by the Z at the end. It's actually ISO 8601. You can change it based on what's designated at the end right there. Unique identifier. So at when the request comes into your stack, just start passing around through your different tiers. Pass an identifier for everything that happens on that specific transaction. That allows you to correlate events across your tier. So there's nothing more painful than trying to correlate like a user got an error, but it happened, we saw it in the web logs, and we're trying to go find it in our services logs and see what the database returned to us. But if we have this identifier, that's all we have to search on. And then you get a nice list of everything that is correlated with that specific request. Include non-PII user data, so like an email address. PII is typically 3 or more pieces of information at once. So, but if you have like user information, also tie it in there. So if you get a complaint from a user, you can say, and you got their email address, you can just search on their email address, and you can actually see everything that happened with them as well. So, categorization. Use multiple levels, info, warning, error, all the good stuff. Assign a priority to it. So this way you can aggregate events based on priority. So you may see something happening over here, and there's a problem, but there may be a bigger problem. There may be like a bunch of P2 events firing over here that may in normal situations might not be that big of a problem, but if you have like this P1 event over here and they're tied together, you might know you have a bigger problem. Profiling data, record timings for everything, your models, your views, your controllers, your backend calls, your services timings, no matter what it is, take a timing of that, dump it in your logs. And that way you can do like, is host 1 processing this the same speed as host 2? Or did this render slow down after this release? And that way you can build nice graphs to actually determine that. So if it did slow down after this release, you can focus on it for the next release to get it back to where you had it. Log structure. Don't make up some fancy, like Apache log structure is horrendous. It's some like big glob of text that like, unless you know exactly where the stuff is, like you can't actually identify what's there. Use key value pairs. It makes it really easy from like a tool perspective too, where you can actually just pull the keys and values out. Splunk loves stuff like this, as well as Logstash. It will make your life a million times easier. So, and then you need to tie it all together. And I think I have, what, like 5 minutes here? Shit. We built our own dashboards internally. All this stuff has APIs. You can build some cool graphs and stuff like that. So if you don't want to build your own, there's tons of free ones or like open source ones out there in GitHub, Gdash, Graphene, like everybody and their mother creates their own because really they want it how they want it. And it's not that hard. I mean, I'm not a designer or I mean, I can code, but you know, I use Twitter Bootstrap and I built that thing on like a weekend one time. You can build cool, fancy things like this so you know actually what services are alerting. And then you can buy some cool big TVs and put it all up there. You would be amazed at how many people just start coming up to see your cool TVs. Everybody will gather. And then at like 3 a.m. on Thanksgiving morning, because we are here and working, because we're, you know, our website is doing some insane traffic, because our sale actually starts on Thanksgiving for .com. You'll just see, like, at one point we had like 100 and some people in this area over here, and it was almost chaotic. We actually had to ask people to kind of leave. But it's, you know, it's a good gathering point. You can see everybody just kind of gather around, and it's fun. We have a good time with it, and you know, it's just cool to just watch in amazement as like your things just, you know, are spiking like crazy. So scale, all these tools are very scalable. Graphite, we were actually pushing about 140,000 metrics per minute off of a single process and single machine. Before we were going CPU bound with the process itself. But Graphite has mechanisms to scale it across multiple machines. So we're actually doing that this year to make sure that when we're at full scale for holiday that we were having some issues basically from the rendering piece of it. We were still collecting the metrics fine. Graphite will actually store things in cache in memory and then dump it to disk. So our cache was a lot higher, but our rendering was struggling because the process was going CPU bound. Sensu, you can run multiple Sensu servers themselves to kind of handle events and handlers and stuff like that. So if you feel like you need more than that, then you can just continue to scale the actual servers themselves. Rabbit also scales very well if you need, you know, that. CollectD, there's really nothing to scale with that. It runs in every single instance and sends off. Logstash, again, uses Elasticsearch, so it's very easy to scale as well. What should you monitor? This is different for everybody. It's hard to answer. You should get KPIs, which are the key performance indicators and critical business processes. So really understand what's important on your site. Make sure you monitor that thing. Make sure that if a customer needs to get from the home page to checkout, that you have like some synthetic monitoring set up that actually does every single step of that, and you're getting alerts when that thing fails. And again, it's different for everybody. It's something you need to decide. System metrics, they're super cheap to collect. There's no reason not to gather everything you can. You may not need it. You may not need it for 6 months. You may not need it for a year. But actually, when you have a problem and you have the metric and you're like, oh, that's actually why this happened, it's very valuable. Instead of going to the postmortem like, yeah, we don't know what happened. Like, I've been in many of those. And you know, the more you collect and the more you do, you won't have to, you know, tell your leaders you don't know what happened. Exactly. So collect it all. Just don't saturate your network. So model view controller timings, get that. Get the bounds of your technologies. Know that your Java JVM starts to crap out at, you know, 300, so you actually alert off of it on 250 threads or something like that. Or get everything it has out of JMX and, you know, request counts. Understand that Apache on this size of machine can handle 2,000, you know, requests or whatever it is. So GC events, this is highly overlooked. Make sure you're logging your GC events, picking it up, understanding when it's happening. it's usually one of those things where like somebody's like, yeah, I don't know why it slowed down. Go look at your GC if you're using something that actually does garbage collection, which most of the stuff does. Erlang, Ruby, Java, they all do garbage collection. So deployments and change. So every time Chef changed something in our environment, we draw a metric. That way we can correlate. If something happens, we can actually draw all of our deployment metrics and say, oh, actually something changed here and something bad happened here. So that way we can easily identify when something changes and when something goes bad. Or hey, maybe we improved something as well. Alerts, we graph all of our alerts as well by system, by metric, and then aggregates as well. And we monitor real time across the United States based on people that are coming into our website. So the more data you collect, the more you can do and build cool visualizations like this. It's actually not that useful, but leaders love this thing. So, other things to look at, Riemann. Riemann is an event processing engine, StatsD, uptime. There's a book, PagerDuty, Water, Selenium. I'm running out of time. We are hiring DevOps, cloud operations, ops managers, monitoring people. If you like this kind of stuff, come talk to me. This is all we do. We're huge web scale, third largest retailer during holiday. Here's my contact information. There's a couple links at the end here. I'm also going to put these on my GitHub page once I just make sure that none of my pictures have anything sensitive in them from a Best Buy standpoint. The repo is private right now, but later today I'll make it public. So if you want my slides, you can have them. Thanks. I'll be outside if anybody's got any questions. I know I like to talk. So thanks.